Okay, new really important vocab word is regular. A regular polygon. Regular doesn't just mean like ordinary, typical, like the regular way that we use the word. Regular in geometry means it's a polygon where all the sides are congruent to each other and all the angles are congruent to each other. So a couple examples of regular polygons that you're comfortable with are squares. All four angles are right angles, so all four angles are congruent to each other, and all four sides are congruent to each other. So a square is an example of a regular polygon. It's a regular quadrilateral. An equilateral triangle. 60, 60, 60. Equilateral triangles. Those would be regular triangles. All three sides are congruent. All three angles are congruent. So the question is, how could you find out the measure of each angle? Because if it's regular, each angle, all the angles are going to be the same. So if they're all the same, couldn't we figure out the measure of just one of those angles if we know it's regular? Well, we know the total. We know the sum of all of the interior angles. So if we know the total, if we know the sum, can't we figure out just one if they're all going to be equal? So if you think about a pentagon, if we have a regular pentagon, that's not a regular pentagon, but we're going to go with it. That means all the angles are going to be congruent to each other. If the sum of all the angles is 540, then we're going to put a fifth of them in that angle, 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 and a fifth of them in that angle. So we're going to take the total and divide it by the number of angles. There's 5 angles in a pentagon. So each angle is going to be 540 divided by 5, which is 108. So each of these individual interior angles in this regular pentagon are all going to be 108 degrees. And we can do the same thing with a hexagon. You take the total, which is 180 times 6 minus 2, which is 720, divided by 6. So in a hexagon, a regular hexagon, each individual angle is 120 degrees. A decagon, the total is 1440. And there's 10 angles. If it's a regular decagon, each of those 10 angles would need to be 144 degrees. So the moral of the story is I am going to take the total number of degrees, the sum of all the interior angles, which we already determined was 180 times n minus 2. And I'm going to divide by the number of angles. Well, if n is the number of sides, then like this pentagon has 5 sides, it also has 5 angles. So n is both the number of sides and the number of angles. So I'm going to divide it by n. I'm just going to divide it equally amongst all of the angles. And again, this formula only works for regular polygons. If it's regular, all of its angles are congruent. So I'm just going to take the total and divide it by the number of angles.